All right, guys, before we get started on today's notes, are there any questions about any of the assignments thus far? Any questions over any of the homework assignments thus far? There was not one Friday. Because the one, if we did have one Friday, it would have been over this, but we didn't finish it. So the assignment will be today. So where we left off on Friday is we did addition and subtraction. We went over doing addition and subtraction of functions and then evaluating the function. Now what we're going to be looking at today is multiplication and division. Now for this first one here, we're finding f times g of x. F times g of x. And then we're going to evaluate f times g of 9. So we're evaluating this function when x is 9. Now this notation here, f times g of x, is the same as saying f of x times the function g of x. We're just multiplying those two functions together. Now for this problem here, f of x is the function x squared. And our function g of x is the square root of x. So we're multiplying x squared and the square root of x together. Now, for the most part, if they were both radicals, they both were the same radical, both square roots or both cubed roots, we would multiply what's inside together. But unfortunately for this here, we have one that's x squared and one that's square root of x. They're not the same. We don't have both radicals or both have the same base. So for us to be able to multiply these together, we could just multiply them and say x squared times square root of x. But we want one variable. So what we need to do is rewrite the square root of x as a fractional exponent. And this is going back to our property that the nth root of a to the x is equal to a to the x over n. Yes. So we're going to rewrite the square root of x as a fractional exponent. Now the denominator is the index of our radical. Since we don't have one written, it's going to be what? 2. Is if there's not an index written inside the radical, it's understood to be 2. Now is there an exponent attached to our x? No, so it's understood to be 1. Because the square root is the same as the 1/2 power. Now we can actually multiply these together and get a single term, a single variable. Because anytime we multiply like bases, we add the exponents. So here we're saying that we have x to the 2 plus 1/2. Now for us to be able to add 2 and 1/2, we need the denominators to be the same. So we need both denominators to be 2. Well, the 1/2 is just going to say 1/2. It's already got a denominator of 2. But we need to change 2. So that's dividing by 2. We have a denominator of 2. And it would become 4/2. Because 4/2, 4 divided by 2 is 2. We're simplifying or rewriting it so that the bases are the same. Because we're really just multiplying 2 by 2 over 2. Now we can actually add these together, which gives us 5/2. Realistically, we could have done 2 plus 1/2 in the calculator and have it give it to us as a improper fraction. That's 5/2. And this here is our final answer. This is f times g of x. So f times g of x is x to the 5/2. And that right there is half of our final answer, because we needed to find f times g of x, which gives us x to the 5/2. But then we also needed to evaluate this when x is equal to 9. So what that's going to tell us is that, well, we're finding f times g of 9. All we're doing is taking our x to the 5/2 and replacing x with 9. So we're trying to find 5, or not 5, we're trying to find 9 to the 5/2. We're trying to find out what the value of that is. Well, at this point, we could plug this into the calculator to get our answer. And it would be 243, I believe, if I'm remembering correct from last hour. Now, the 2 in the denominator, we got that from the 1/2, our square root, yes? What's the square root of 9? 3. So we could really say that we're taking 3 to the 5th. And look at it that way. So we're taking 3 times itself 5 times, which is still 243. So this here is our f times g of 9. And that right there gives us our 2 answers. Any other questions on any of this here? All right, we can go and look at the next one. Again, we're looking at f times g of x. And then once we find that, we're going to find f times g of 4. So we're going to find f times g of x and f times g of 4. Well, our f times g of x is the same as saying f of x times g of x. We're just multiplying these two functions together. And in this problem here, f of x is what? X cubed. And g of x is square root of x. Now again, for us to be able to multiply these together, we're going to have to rewrite that square root. And if I rewrite the square root, it's going to be x to the 1/2, x to the 1/2. Because our square root is going to be 1/2. And in this case here, it's just 1/2 because the x inside the radical doesn't have an exponent to change the numerator from 1. If we had the square root of x cubed, we would have had 3/2 because that exponent would change it from 1 to 3. Any questions on this here? Well, now we can multiply these together, and because we have like bases being multiplied, we add the exponents. So in the exponent, we're adding 3 and 1/2. Well, to add fractions, we need the denominators to be the same, which means we need to change 3 into 6/2 so that the denominators are the exact same, which gives us 7/2, 7/2. And this here would be our f times g of x. I'm going to rewrite it down here just so we can see it. The function f times g of x and what we're evaluating, f times g of 4. So to evaluate this, we're just replacing x with 4. So we're trying to find 4 to the 7/2. And again, since this is all numbers, we can just plug this into the calculator. One more time. 128. And get 128. We can just plug this in. 4 to the 7/2. Now, again, just like the last one, the 2 on bottom is telling us that we're taking the square root. So we're taking the square root of 4, which is 2, and then we're multiplying 2 by itself 7 times, which gives us 128. And that's it. So we're saying f times g of 4 is 128. And that's all we'd have to do for this here. Any questions on any of this here? Any questions on everything we've done so far today? All right. Well, the next thing we can look at is division, dividing these two functions here. So this here, f divided by g of x, is what we want to evaluate. And once we find what f divided by g of x is, we're going to see what f divided by g of 16 is. We're going to plug 16 in for x. Now this here, f divided by g of x, this right here, is the same as saying f of x divided by the function g of x. We're taking the function f of x and dividing it by the function g of x. We're dividing those two functions from each other. And for us here, what is the function f of x? It is 6x. And g of x is 3/4. Now for these here, they didn't write it in radical form because they didn't tell us that g of x is the 4th root of x cubed. They just went on and wrote it in fractional form. And it would scroll. Now whenever we divide like bases, our x and x to the 3/4, we subtract the exponents. Does the x in the numerator or x in the denominator have the bigger exponent? Does x have a bigger exponent on top or bottom? What's the exponent in the numerator? 1. What's the exponent in the denominator? 3/4, yes? What's bigger, 1 or 3/4? 1, yes? Because if we looked at it as dollars, well, we're comparing $1, well, 3/4 of the dollar is 75 cents. So the 1's going to be bigger. But if we do subtract, we're going to do 1 minus 3/4. Now we can do exactly as we did on the previous one and rewrite 1 so that it has a denominator of 4 and then subtract. But I think we can do 1 minus 3/4 pretty easily, because 1 minus 3/4 is 1/4. And this here would be our f divided by g of x. Now at this point we haven't talked much about the the domain. And the domain is just the values of x that we can actually plug into this function. Now for all the previous ones, like this one here, the domain, well, it would scroll, for this function is going to be all the values of x that are greater than or equal to 0. And the reason that we have this is because the square root of x, we can't plug a negative number in and get a real number out. Because we've solved the square root of -4. because we know the square root of 4 is 2, but the negative comes out as I. So we can't take the square root of a negative number. So if we're talking about the domain for functions like this here, we're just saying that x is greater than or equal to 0. Another way we can see this is actually just graphing the function and seeing where does it show up on the x-axis. Where do we have x values for? Now, for these functions here, and I just want to point this out, the domain for this is still going to be x. It's still going to have 0. But this time it's just going to be greater than. X is greater than 0. And the reason for this is because of g of x being in the denominator, since we're dividing by g of x. Because any value that will make g of x 0 will not work. Well, that would be 0. We can't include it. But that's just mainly a side note. Now, the last thing we need to do is evaluate this when x is 16. So we're taking 16, or 6 times 16 to the 1/4. And again, we can plug this into the calculator and get 12. So our f divided by g of 16 is 12. And really what we're looking at is 6 times the 4th root of 16. We're trying to see what times itself 4 times is 16, which is 2. And 6 times 2 is 12. Because again, 1/4 power is the same as the 4th root. Any questions on any of this here? Let's go on and look at the next one. So we're going to find f divided by g of x. And then once we find that, we're going to find f divided by g of 27. We're going to plug 27 into that function. And again, f divided by g of x is the same as saying f of x divided by g of x. F of x divided by g of x. And in our case here, f of x is 4x. And g of x is x to the 2/3. Now again, we can do exactly what we did on the previous one and write this as 4 times x to the 1 minus 2/3. Or we can just simplify what 1 minus 2/3 is, which is 1/3. We can go and subtract it. We don't have to necessarily rewrite that because it's just subtracting those two together. We're just subtracting 1 and our 2/3 to get 1/3. And that tells us what f divided by g of x is. Any questions on this here? Now we're just finding 4 times 27 to the 1/3. And indeed it would be 12. Because again, our 1/3 is just taking the cubed root. We're trying to see what times itself 3 times is 27, which is 3. And 3 times 4 is 12. Any questions on any of this here? Do we feel comfortable with those here? Yes. All right. In that case, We're going to skip the next two and just go on to the last thing we'll look at, because I feel like y'all are feel pretty comfortable with what we did on Friday with addition, subtraction, and what we just did with multiplication and division. Now the ones on the homework will look similar to these here. Essentially, it'll give you f of x and g of x and ask you to do addition, subtraction on both. You're doing both operations with it. Now the last thing we're going to look at today is performing these operations using technology. So we're going to find f plus g of 2, f minus g of 2, f times g of 2, and f divided by g of 2. We're going to be plugging 2 into x and finding what these are. But instead of using what we've been doing where we find out what f plus g of x is, or f minus g of x, and then evaluate it, we're just going to use the calculator to do it for us. Now in the graphing calculator, the first thing we're going to do is hit y equal. We're going to input these functions in. So in y equals, we'll plug in, so for y1, we're going to plug in the first function, second square root of x. We're going to plug f of x into y1. And for y2, we'll plug in g of x. So you say second square root of 9 minus x squared. And we're going to type these in and let the calculator do the evaluation for us. If you need a graphing calculator, you can go grab one. Now, a lot of times at this point here, we would go on and just graph it to see what it looks like. And these would be our two functions. But we're not going to actually use the graph to find out what f plus g of x or f minus g of x or any of these are. But it does help us see what the domain and range are. As it works out for the second one, well, scroll up just a little bit. We only actually have values for g of x between -3 and 3. Those are the only values that work. And for f of x, we only have values for when x is greater than or equal to 0. Those are the only values that work for the domain. But we're going to go second quit. We're going back to the home screen for us to be able to do these here. And we want to evaluate these when x is equal to 2. Now the next thing we're going to do is we're going to go alpha trace, alpha F4, and it will bring up this menu. And what this is telling the calculator, what we're telling the calculator is I want you to use these functions. So I'm going to hit enter with y1. So I'm wanting it to calculate and use the function y1. Use parentheses, 2, close parentheses. And typing this in, what we've told the calculator is I want you to take the function in y1 that we typed in and plug in 2 into that function. So we've taken f of 2. Now what we want to do is we want to add to it g of 2, because we're taking f plus g of 2, so f of 2 plus g of 2. And to get g of 2, we're going to do the same thing. So alpha trace, but this time I'm going to go down to y2 and hit enter. And do the same thing. So what it's telling the calculator is I want you to plug 2 into y1's equation and add to it the value when we plug 2 into y2's equation. That's what we do next. Enter. And it gives us the value. So for this one here, we don't have nice values like we've had on the previous ones, but f of 2 plus g of 2, or f plus g of 2, is 3.65028.154. And that's our value. Now, unlike the previous ones that we've done, if I wanted to move on to f minus g of x, well, I had to actually figure out what that was, subtracting our terms. But here, we could do the same thing we just did, alpha trace y1 parentheses 2 close parentheses minus alpha trace y2, parentheses 2, close parentheses. Or we can come up here, highlight it, and hit enter. And cursor over to the plus and change it to minus, and hit enter. And we get that f of 2 minus g of 2 is negative 0.821854451. And we can do the exact same thing with multiplication. Times. And lastly, we can do the exact same thing with division. And we get 0.632455532. And that's how we can use the calculator to evaluate these here, which does make it a little bit easier because now I'm not having to actually figure out what the condensed version of each one of these here. I'm not having to solve f plus g of x to see what the function is and plug it in there. We can actually use the calculator to do this. But that's it. That is all we are doing for 5.5.